Assalamualaikum to lecturer of technology workshop, Encik Akmal, and to all my beloved friends. Today I would like to present chapter 9, Arc Welding. So my name is Muhammad Adham, and all my members, Muhammad Adam, Muhammad Amirul Kamal bin Roslan, Muhammad Imam Afifi, and Tinesh. Okay, I will start with the terminology of straight polarity and reverse polarity. Straight polarity and reverse polarity. AC current welding or direct current welding. AC current welding is equal straight polarity and reverse polarity. Direct current welding circuit may be either straight or reverse polarity. If set on straight polarity is equal, electron flow from the electrode to the plate, concentrating most of the heat on the work. Set on reverse polarity is equal, the flow of electron is from the plate to the electrode, thus causing a greater concentration of heat at the electrode. Electrode tends to melt off. Direct current reverse polarity DCRP requires a larger diameter electrode than direct current straight polarity DCSE. That's all for my topic. I will pass to the Tinesh.
Saya Tinesh dari kelas DKM 1A. So, hari ini saya di sini untuk menerangkan apa itu 7.1.54b, list the characteristics of polarity. So, biasanya polarity ada dua jenis, iaitu DC straight polarity dan DC reverse polarity. So, apa itu polarity? Terdapat dua jenis polarity, iaitu straight polarity dengan reverse polarity. AC current welding or direct current welding, dua jenis welding ni kita boleh dapat daripada straight polarity ataupun daripada reverse polarity. So, AC current welding akan mendapatkan kita akan dapat from straight polarity plus dengan reverse polarity. Apabila kita cantumkan dua jenis polarity ini, kita akan dapat AC current welding. So, direct current welding circuit may be either straight or reverse polarity. Direct current welding ini kita boleh dapatkan daripada reverse polarity ataupun daripada straight polarity. If set on straight polarity equals to electrons flow from the electrode to the plate, concentrating most of the heat on the work. Set on the reverse polarity equals to the flow of electrons is from the plate to the electrode, thus causing the greater concentration of heat at the electrode. Electrode tends to melt off equals to direct current reverse polarity DCRP requires a large diameter electrode than direct current straight polarity DCSP. So, characteristics of polarity, biasanya dia ada dua jenis polarity, iaitu DC straight polarity dengan DC reverse polarity. Untuk DC straight polarity, dia punya lubang tu, the hole, deep penetration, narrow weld. Maksudnya lubang ni lebih mendalam dan tidak seluas dengan reverse polarity. So DC reverse polarity, dia punya lubang tu shallow penetration, wide weld. Dia punya lubang tu tak berapa dalam seperti DC straight polarity, tapi dia punya lubang tu, dia punya penetration itu dia wide, dia luas. Okay, so seterusnya 7.1.5 part C, the procedures to choose the type of polarity. So, electrode negative and electrode positive used in DC welding. DCEN, iaitu DC electrode negative, electrode connected to the negative terminal of power source and were connected to the positive terminal. DCEP, DC electrode positive, electrode connected to the positive terminal of power source and were connected to the negative terminal. Switch changes to either electrode positive or electrode terminal. Okay, so itu saja daripada saya. Terima kasih semua. Thank you.
Okay, Assalamualaikum. My name is Adam and I will present. Uh, I will talk. I will show. I will do my sketch and label about arc welding process. So this is the sketch I do. The process now here. Electrode holder, electrode lead cable. So this big one is arc welding power source. So this is if we put in the plug, so plug to power source. So this cable input power lead. So this wire is for workpiece connection clamp. Oh, we call clamp. Okay, this one is for electrode for arc welding. So we do electrode holder, electrode lead cable, electrode. Okay, this one is workpiece or piece metal. If we want to try or doing some project, we will do at the metal before doing the real one. Okay, this is the welding table. Welding table is metal for sure. Okay, that's all for me. Thank you.
Hello everyone. Today I'm about to bring for my topic is analyze the effect of arc length, electrode angle, and the speed of travel on the welding product. So okay, arc length. After striking the arc, maintain a 1/8 electrode diameter distance between the electrode and the workpiece. If the effect if the arc length becomes too short, the electrode will get stuck to the workpiece or short out. This is an example of what will happen. You see? Okay. If the arc length become too long, spectral undercut and porosity can occur. Like there is, it's a bit crack here. Arc length 1/8. Example. Arc welding is a constant current process, but the arc length has an effect on voltage. Reducing the arc length will increase the voltage, and this reduces the heat in the weld. Increasing arc length will increase the voltage. Equals diameter of electrode. Short cracking sound best for most welding. Lockout. Steady heat allow oxidation as pattern. Now we go to the electrode angle. Electrode angle we have two. There is work angle and travel angle. Work angle is the angle from the horizontal measure at right angles to the right direction of welding. Work angles can vary depending on the position the weld is being made in. The angle between the electrode and the work is depicted on the left. So you can look from here, you can hold it about 19 degrees. Travel angle. Travel angle are also commonly called lead angle. Travel angle is the angle in the direction of welding and may vary from 5 to 30 degrees depending on the welder, the choice and condition. Okay. Now we go to the travel speed. Travel speed is speed at which the electrode moves along the base material while welding. The maximum speed of welding depends on the skill of the operator, the position of the weld, the type of electrode, and the required joint penetration. When the travel speed is too fast, the molten pool cools too quickly, locking in impurities and causing the weld bed to be narrow with pointed ripples. If the travel speed is too slow, the metal deposit piles up excessively and the weld is high and wide. The travel speed impacts the shape of the bed. From here is the crater, shape ripples, and The neck is a uniform width. This is a sample of the effect. Normal well, it will become like this. Current to low, current to high, speed to fast, speed to slow, out to long. Okay, that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, pada saya akan menerangkan this method in starting an arc welder. Starting the arc. Arc welder don't have a button to start the arc. Unlike MIG welder, the rod strut will become live as soon as the machine is switched on. The arc is started by touching the electrode from the circuit before rising the electrode to establish the arc. This need to happen quickly to avoid welding the rod to the work. And sketch starting, type starting and sketch starting are the two common methods of starting the arc. Tap starting. A sharp tap of the rod against the words will remove excess flux from the end of the vertical contact needed to start the arc. Section should allow the momentary contact with the work before quickly pulling the rod a short distance away. Too heavy a contact or too slow an action can cause the rod to stick. In the video, the auto darkening helmet as the arc is started. The light is bright at first because the outline is initially too long. The outline is quickly reduced to the correct distance for welding. Rods start much more easily on the second attempt. It is good practice to first start the arc on at the beginning of the weld. Ini cara-cara untuk step starting. Itu contoh untuk step starting. An alternative starting method is to lightly scratch the rods against the works. Moving the rod against the works remove excess flux from the rod and allow electrical contact from the steel in the middle. As soon as the rod starts to spark, it is lifted from the works to start the arc. In the video, a backward and forward scratching motion is used to remove the flux coating. A limited movement should mean the arc will start somewhere close to where you want to start. When the first spark is seen, the rod is pulled away from the wood to prevent sticky, and then it is returned to the normal arc length for welding. The scratch start technique is more prone to sticking as it relies on human reaction times. This can be a useful technique for difficult to start rod or for AC machines and those with low open circuit voltage which make tap starting more difficult. As excessive pressure on the rod while scratching will increase its chance of ticking. So ini video untuk kita scratch starting lah. Sama. kami bulan 2. Sekian wabillahi taufiq. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.